Okay, so isometric projection means it is nothing but a projection of solid or combination of solid by inclining at an angle of 30 degree from any one of the reference points. Okay, so wherein we can see in isometric projection, so there will be 30 degree angle lines. So using those lines we are going to project. So it is nothing but a complete 3D picture of the solids or a combination of solids. Okay, by inclining them at an angle of 30 degree from any one of the reference points. So how do we construct the isometric projection? So here we have two methods. One is box method, one is 4 arc by center method. Using these two methods we are going to construct the isometric projection. And here in when any one of the solids given, right, so it will be having two distances. One is vertical height, another one is horizontal distances per given in any one of the solids. Okay, so vertical heights given in solid will be drawn vertically in the isoscale. Okay, vertically in the isoscale, so there is no change if the vertical heights were given. Okay, so that will be drawn vertically in isoscale. But if any of the distances were given horizontally, so the horizontal distance were drawn in the 30 degree inclined lines. So in the isoscale, so there are 30 degree inclined lines for the right. So in those lines we are going to draw the horizontal distances. Now we come to the sphere. Okay, sphere is the only solid which will be drawn with the actual scale here. Okay, because except sphere, all the solids will be drawn with the isoscale. So in sphere, what happens exactly here? If we are going to tilt a sphere at whatever the angle, 30 degree, 40 degree or 50 degree, we will get the same circular weave here, the top weave, front weave. Okay, so by inclining at whatever the angle, 30 degree, 45, 60 degree, we will get the same weave. That's why the sphere will be drawn with the actual scale. Okay, so remember, so sphere will be drawn with the actual scale. Except sphere, all the solids were drawn with the isoscale in the isometric projection. Okay, today we are going to start about isometric projection. Okay, so isometric projection, it is nothing but a projection of a solid or a combination of solid by projecting at an angle of 30 degree here. Okay, so you can see here we have 30 degree inclined lines. Using these lines we have to do the isometric projection. So in this isometric projection, so we see the first problem. A sphere of diameter 50 mm rests centrally on top of a cube of size 50. So there are two solids given, one is sphere and one is cube. Cube of size 50 and sphere of diameter 50. So you can see that sphere of diameter 50 rests centrally on a top of a cube. That means first we have to construct a cube here of dimension 50. Then after that we have to do the sphere. Okay, first I'm going to draw a reference line here. Okay, so reference line I'm drawing here. Okay, I'll take reference point here. So now we are using box method to construct the cube here. So cube of sides 50 mm. So I'm drawing box of 50 here. 5 box. 1, 2, 3, 4, 5. Okay. And similarly 1, 2, 3, 4, 5. And we have 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. So box of 50 mm it is drawn. Now we know that in a cube we have vertical height also same thing, that is of 50 mm. 50 mm is again 5 box. 1 vertical height 1, 2, 3, 4, 5. Same thing here 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. Same thing here 1, 2, 3, 4, 5. Okay. So now we have to join with the top face of the cube. Okay. Joining with the top face of the cube here. So you can see that we have constructed a cube. It is somewhat similar like a hexagon. Okay, so we have constructed a cube. Above it, centrally we have to place a sphere of diameter 50. So centrally means first we are going to find out the center of the top face. Okay, center of the top face. Here it is 50 means exactly at 50 means 2.25. 25 means 2.5. We are going to mark. Okay. Okay, this is our center point. So from this center point, you see we have to construct a sphere of diameter 50. We have to consider a height of 25. Say 5, 10, 20. So 25 here, 15, 5 here, 15, 25. So this is what the center point. And here a sphere will be drawn with the actual scale. Okay, sphere is the only solid which will be drawn with the actual solid. Except a sphere, all the solids will be drawn with the isoscale. Only the sphere which will be drawn with the actual scale. Okay, remember it. So sphere will be drawn with the actual scale. So always remember it, because if we are going to incline sphere at whatever the angle, it is 30 degree, 40 degree or 50 degree, will get the same circular shape only. So there is no change in the shape in case of your sphere. Okay, so remember it, sphere will be drawn with the actual scale. So this is our sphere and this is our cube. So you can show the angle. Here it is 30 degree and here also 30 degree. Okay, sphere will be drawn with the actual scale. So remember it. So this completes the problem. You see the second problem in isometric projection. So you can see the question. Here in two solids given, one is hemisphere. Okay, hemisphere of 40 mm diameter. Hemisphere means it is nothing but the half part of the sphere, supported coaxially on the vertex of a cone. So the second solid given, it is cone. So for that cone they have given base diameter 60 and axis length 50. So that means we have to construct the cone first, then after that we have to construct the hemisphere. Hemisphere means half part of the sphere. Okay, now flat circular face of the hemisphere facing upside. Okay, so first we are going to construct the cone here. So for the cone, the base diameter given 60. Okay, so first we are going to take the reference line here. Okay, reference line. So here you can see that base diameter 60 means we have to do the 6 boxes here. 1, 2, 3, 4, 5, 6. Again here 1, 2, 3, 4, 5, 6. Again 1, 2, 3, 4, 5, 6. So we have to construct the 6 boxes either side. The 6 box it is constructed. Now you see that the base part of the cone, it is which is given with the diameter 60, means it is in circle. Okay, so when the circle it is constructed in iso, it will become ellipse. Okay, it will become ellipse. So how to construct the ellipse, I will show. So herein to construct an ellipse we have to go for 4 arc by center method. Okay, first I am going to mark the middle point of all the edges. If it is 60 means exactly you can mark at 30 here. Okay, 30. Now I am drawing the lines here like this, arrow lines you can draw here. Okay, so like this 4 lines you have to draw. Then after that we have to use compass here. Okay, using compass, by measuring this length, okay, I have to draw first arc. Okay, and again from this point, so measuring this length, so measuring like this. Then third point we have to measure this from this point using compass. Third arc, next fourth. Measuring again this distance. Okay, so we have constructed an ellipse. Okay, so this is what the base diameter. When it is constructed an ellipse, it becomes a it is a base part of the cone 60 mm diameter circle converted into ellipse in the ISO. Now we have to find out the center. We have an axis length, right? So center of the box here, like this. This is the center of the box. From this we have to consider a axis length of 50, that is 5 boxes. 1, 2, 3, 4, 5. So draw an vertical height of here 60. Now we have to draw an connecting tangentially. We have to connect like this tangentially to make sure the surface of the cone has to touch like this. So this completes the cone problem. Now we have to place the hemisphere, which is having a diameter of 40. So 40 means again we have to construct a 4 box here. 1, 2, 3. That is 40 mm box means 4 box. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it is done. Okay, 4 boxes. Again you can see that hemisphere means it is a half part of the sphere, so it is in circular. So when it is constructed, it is circular means when it is constructed in ISO, it will become ellipse. Okay, so again I am marking the middle points here, the point of the box. Now using compass we have to cut the arcs here. This length. Okay, again from this point, so measuring this length. Okay, so it is done. So now again we find out the center of the box here. Okay, from this center point, so how to construct the lower part here from this point to here, exactly here we are going to take and then join it like this. Okay, so this completes the problem. Here you can see this is our 30 degree, so this it is cone and this is hemisphere. You can see that this flat circular face, it is facing upside. So this completes the problem. So you can like the video. So herein we will be encountering frustum in isometric projection. Frustum means it is nothing but a cutted portion of the solid. Okay, cutted portion of the solid. So we encounter two types of frustum here: frustum of pyramid and frustum of cone. Okay, so what happens in the frustum of pyramid, it is if it is given frustum of square pyramid means, so both the top face and bottom face will be in square here. Okay, will be a square with the height, that is axis height is given. Okay, so that's what the frustum of square pyramid. You can see frustum of pentagonal pyramid or hexagonal pyramid means say the top face and bottom face will be same here. In the same case we can find in the frustum of cone also. In frustum of cone, the top face and the bottom face will be in circle here, So with the height or axis it is given. Okay, frustum means understood, it is nothing but a cutted portion of a solid. Okay, that's what the frustum is. Okay, we see another problem in isometric. So here in this problem they have given the frustum of a square pyramid. Frustum means it is cutted portion of a square pyramid of sides 40 mm and height 60 mm and top is 20 mm. Okay, so frustum means understood it is a cutted portion of the square pyramid, wherein the top face and the bottom face will be a square. The top face it is 20, bottom face it is 40 and height given 60. So rest on the center of a top of a square block. So okay, square block of side 60 and height 20. So first we need to construct a square block of 60 and height 20. Above it we have to place a frustum of the square pyramid. Okay, so first I'm going to construct a square block. Okay, so square block I'm constructing here, just taking reference point here at this point. Square block of base side it is 60, that means 6 block. 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6. So we need to construct a box of 6 here for the 60 mm. Okay, so now you can see that vertical height of 20. So height of 20 means from all these corners we have to consider a height of 2 boxes. So now we are going to join it. So square block it is constructed. Now you see that we have to construct a frustum of square pyramid of sides 40, base side it is, and height 60 and top is 20. So we need to get a square of 40 here, but here in we have 60. So how to get the 40 means herein we go for the subtraction of the box method, that is say 60 minus 40. The base we have, that is 60, we require 40, so it means 20. 20 by 2 means it is 10. So we need to subtract by 10 mm on each side. Okay, so 10 mm means one box distance. Okay, understood. So 60 minus 40, 20, 20 on either sides being divided by 2, so it is 10. 10 means one box, so we need to subtract by one box on either sides. You can see that. So on either side we have to subtract. Okay, so it is nothing but subtraction of the box method. Okay, subtraction of the box method. So it is done. Now we see that, so this is our box. Okay, this is our square box. Okay, so you can see that square box it is constructed. Height also we can give 6 box, and then top face of 20. So in order to do that, another box of 20 required at a height of 60. So how to do that? Say from this 40 mm box I will be considering 6 box distance here. 1 2 3 4 5 6 here. Okay, similarly from this end 1 2 3 4 5 6. Again from here 1 2 3 4 5 6. Again from this end 1 2 3 4 5 6. So another box you can construct here, that is 40 by 40. Don't draw vertical line here. So we have to construct a frustum here. Okay, you construct here box of another 40, but we here the top face we require a box of 20. It's again subtraction of box method. So 40 minus 20 is 20 on either side means divided by 2, so we get 10. So subtract by 10 on either side. Okay, subtract by 10 on either side. So this inside box, okay, this inside box is our 20 by 20. So it is 20 mm box it is. Okay, here we have this box, which is this one. I'm going to dark it 50 by 40. So this from here to here we have to join, again from here to here, from here to here, from here to here we have to join. Okay, so because it's a square pyramid and we have slant edges, right? So we can show like this. So we have to construct. So this completes the problem. This 30 degree and this is 30 degree. This is square block. This is frustum of square pyramid. Okay, so this completes the problem. Okay, we do another problem in isometric. So you can see in this problem, so there are two solids given. One is cone of base diameter 30 and height 40 mm, rest centrally over a cube of side 50. So first we have to construct a cube. Okay, cube of dimension 50. So over it, so we have to construct a cone here. So cube of dimension 50 here, 5 sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. Okay. Okay, vertical height of 50 here. That's 5 boxes. One, two, three, four, five. Okay. 1, 2, 3, 4. So it is also 5. So cube of dimension 50 it is done. Now centrally over it we have to place a cone of diameter 30. Okay, cone of diameter 30 means say subtraction of box meter is 40 minus 30. So 40 minus, sorry, it is 50, right? 50. So this is 50. We need to get a cone of base diameter 30. So 30 means 20 divided by 2 means 10. So 10 on either side. So we subtract by 10 on either side diagonally like this. So here we get a square of 30 here. Okay. So base diameter means it is in circle. So that means so we have to go for 4 arc by center method by marking the middle points. So using compass. we construct a cone. So cone of height 40 here. Axis from exactly center. Center point. So 1, 2, 3, 4. So axis height 40 here. Connect tangentially here. Okay. So this completes the problem. See this problem number 10 in isometric. A pentagonal pyramid of base side 30 and axis length 60 is resting on HP on one of its base side, base with the side perpendicular to VP. So first we have to construct a pentagon with respect to 30 mm dimension. With the actual scale we have to do it. Then after that we have to construct the box here. Okay, we need a box to construct the pentagonal pyramid. So we have to construct the box here initially. Okay. So like this we have to construct the box here, and now we have to find out the dimensions here. Okay, so this is around 28 we're getting 28 something, 28.5 something. So these dimensions we require. How much we have? 28 point something, and these dimensions also we require here. So it is how much is around 25. Okay, and then this dimension also required. This is around 9 mm we get it. Okay, 9 mm. Okay, so here in what I will do, I am going to give this is A, B, C, D, E, and for this box I will give 1, 2, 3 and 4. So now using this box dimension we can easily construct the pyramid here. So I will be taking this reference. Okay, now so first I'm going to measure this box dimension. This is around 49 we have. It is around 49. Okay, it is around 49, and this is around 45. Okay, so 45. So that means if I am starting from 1 here, okay, if I am starting from 1 here, so 1 to 2 we have 49. Okay, 1 to 2 we have 49. 1, 2, 3, 4, 5. So less than 5 I am going to mark approximately 49 here. Then similarly here 45. So 2 to 3. So this is 2. 2 to 3 we have 45. 1, 2, 3, 4, 5. So exactly here I am going to end here. So this is 0.3. And again 3 to 4 I have 49. So 49 means 1, 2, 3, 4, so 5. So around I'll be getting 1, 2, 3, 4, 4. So somewhere here I have to get. So this point we have 4. So now we can join it. So now 1 to 2 it is 49, 2 to 3 it is 45, again 3 to 4 is 49, again it is 45. So we have to construct the box first. Box of box it is done. Now you can see that from 1 to A it is 9. 1 to A it is 9, around 9 I mark 1 to A 9. Again from 2 to B is also around 9 mm, so it is 2 to B. Okay. Then 2 to 3 it is 28. So 10, 20, 20, 28 means here we will get this is C. Again 3 to the D is 25. Okay, approximately I'm going to mark 10, 20, 25. I'm going to mark here. This is D. And again from 1 to E it is 28. 1 to E it is 28. So now we are going to join. So this completes the pentagon. Okay, now we have to take center of this pentagon. Approximately I'm going to draw 3 lines here, perpendicular bisectors. Okay, 3 lines if I draw with the center. Okay, center point I am getting. So the axis length it is 60. From this point you have to consider a axis length of, say, vertically here. We need to count the box. So just I am keeping this scale for reference. We need to count the box. Okay, from this end 1. So 1 we have this 1, 1, 2, 3, 4, 5, 6. Okay, here. So vertical it is axis. We have to draw for 6 boxes. Okay, we have to count the boxes here. 1, 2, 3, 4, 5, 6. Okay, now we are going to join with the slant edges. Okay, so this completes the pentagonal pyramid. Okay, so this completes the pentagonal pyramid. We do another problem on isometric. You can see here we have to construct a sphere of diameter 45 centrally over a frustum of cone base diameter 60, top face 40 and height 60. So that means first we have to construct a frustum of cone. So 60 means 6 boxes here. 2, 3, 4, 5, 6. 3, 4, 5, 6. Okay, 60 by 60 box. So middle points we have to mark. So top face center, so height of how much, 60, that is 1, 2, 3, 4, 5, 6. So here also 1, 2, 3, 4, 5, 6, another box. Okay, 60. So within this box we have to take 40 means 10 mm on either side. We'll get a box here by subtraction of box method. So subtraction of box method, getting can construct another ellipse here. Okay. So another ellipse it is done. So above it we have to construct 2.5, that is here exactly the center, to take 22.5. So 22.5 will take, and here I'm going to draw a circle. Okay, so this is nothing but a sphere. So this completes the problem. Okay, we solve another problem on isometric. So it is problem number 15. So we have to construct a hemisphere of diameter 50 is centrally resting on a top of a square prism of base side 60 and height 30. So on the square prism we have to construct a hemisphere. So first we have to construct a square prism, okay, of base side 60. So base side 60 it is 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6. Okay, so you have to construct a box of 6 here. So height how much given? 30. 30 means 3 boxes. 1 2 3. Vertical height of 30. Cube it is constructed, cube of 30. Now we have to construct a hemisphere. Okay, hemisphere of diameter 50. Okay, for that I'm going for a box subtraction of box method. So here it is 60. Okay, 60 minus 50 means it is 10. 10 divided by 2 means it is 5. So on either side we have to get a box of 50 means, so on either side diagonally exactly the midpoint. So we get it here. See that box of 50 here. You can count to 1 2 3 4 5. Okay, box of 50. But we need to construct a hemisphere of diameter 50 center resting top of square prism, but such that it curved surface of the hemisphere touching the top face. That means curved surface we have to get it here. That means we have to go construct a hemisphere at a height of 25 here. So diameter 50 means height of 25. So height of 25 we have to construct another box here. 1 2 2.5 here. Similarly 1 here, 2.5 here, 1 2.5. So here 2.5, another box of 50. Here we get at a height of 25. Another box you have to construct. Okay. So after constructing it, again for Agui center method, marking the middle points. So 5 means 20, 1, 2, 3, 4, 5. So 25 means here. Exactly 25, 20, 25, 25. So construct ellipse here. Okay. So now we can draw here diagonal. Okay. So from exactly the center, so measuring this length, so I can construct the curved face of the, you can see that here, curved surface. So we are going to find out the center first, okay, then we'll take the length. Okay, so to find out the center, it's exactly the center points you have to take. Center point here I'm getting. So this completes the problem. Okay, we solve another problem on isometric. So it is problem number 15. So we have to construct a hemisphere of diameter 50 is centrally resting on a top of a square prism of base side 60 and height 30. So on the square prism we have to construct a hemisphere. So first we have to construct a square prism, okay, of base side 60. So base side 60 it is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So you have to construct a box of 6 here. So height how much given? 30. 30 means 3 boxes. 1, 2, 3. Vertical height of 30. Cube it is constructed, cube of 30. Now we have to construct a hemisphere. Okay, hemisphere of diameter 50. Okay, for that I'm going for a box subtraction of box method. So here it is 60. Okay, 60 minus 50 means it is 10. 10 divided by 2 means it is 5. So on either side we have to get a box of 50 means, so on either side diagonally exactly the midpoint. So we get it here. See that box of 50 here. You can count to 1, 2, 3, 4, 5. Okay, box of 50. But we need to construct a hemisphere of diameter 50, center resting top of square prism, but such that it curved surface of the hemisphere touching the top face. That means curved surface we have to get here. That means we have to go construct a hemisphere at a height of 25 here. So diameter 50 means height of 25. So height of 25 we have to construct another box here, 1, 2, 2.5 here. Similarly 1 here, 2.5 here, 1, 2.5. So here 2.5, another box of 50. Here we get at a height of 25, another box here to construct. Okay. So after constructing it, again 4 argway center method, marking the middle points. So 5 means 20, 1, 2, 3, 4, 5. So 25 means here. Exactly 25, 20, 25, 25. So construct ellipse here. Okay. So now we can draw here diagonal. Okay. So from exactly the center, so measuring this length, so I can construct the curved face of the, you can see that here, curved surface. So we are going to find out the center first, okay, then we'll take the length. Okay, so to find out the center, it's exactly the center points we have to take. Center point here I'm getting. So this completes the problem. Okay, today we are going to do another problem in from CAD solution book, that is problem number 41. So you can see in this problem we have to construct a cube of set 25 rest centrally on a rectangular slab of 100 into 40, thickness 30. So first we have to construct this rectangular slab. Above it we have to place the cube. Okay, so for that, so take a reference line from this. This is 100 into 40 rectangle. So 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4. Okay. Again 1, 2, 3, 4, 6, 7, 8, 9, 10. So thickness we have to consider, that is 30. 30 means 3 box. 1, 2, 3. The rectangular block done. Now we have to construct a cube of side 25. So here one side having 100, another side having 40. So 100 minus 25 is equal to 75. It is 37.5. Another it is 40. 37.5 here. Okay, now in the 40 mm box you have to construct by 7.5, 7.5, 7.5, 7.5. So here cube of height 2.5, 1, 2, 2.5. One, 2, 2.5, 1, 2, 2.5. So this is what the rectangular block with respect to the cube. We do another problem in ISO. So in this problem given hemisphere of diameter 70 placed on the ground on its curved surface. So the cone of base diameter 70 and height 70. First we need to consider a cone, and above it we have to construct the hemisphere. Okay. So hemisphere, cone of base and height placed centrally on it. That means first we need to construct a hemisphere. Sorry. So this is hemisphere first, second we have to construct the cone. So you can see that first is the hemisphere we have to do, second is the cone we have to do. Okay, so how we do that? Here hemisphere 70, so 1 2 3 4 5 6 7. Okay, 7. So we need to get the curved surface at a height of diameter 70 means 3.5. 1 2 3 3 and a half. 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 So here also another box we have to construct. Okay. Now mark the middle points here. marking the little point of the box here. Okay. Okay, so it is done. Now from this end we have to measure this length and we have to draw like this. Okay. So it is done. So hemisphere it is done. Now we have to draw the cone. So for the cone having a height of 70. So 1, 2, 3, 4, 5, 6, 7. You can see that. So box of 70. Okay, now we have to connect this. So tangentially. Okay. So this completes the problem. Okay. So we do this problem number 34. So in this we have to construct a sphere of diameter 60, place central in a top face of a hexagonal prism, side 35 and height 50. So for that hexagon we have drawn an orthographic it and then we have drawn the box for it. Okay, so box dimension is very important. One side 70, second side is 30 and the other sides we have been marked. Okay, so first we need to construct a box of 70 by 60. Okay, so from this end 70 means 7, 1, 2, 3, 4, 5, 6, 7. Here. And then 60. 1, 2, 3, 4, 5, 6. So 70 by 60. So this is 70, this is 60. So here, so this is 1, 2, 3, 4. So now done 1, 2, 3, 4 box done. It is A, B, C, D, E, F. Now 1 to A. So 1 to A, you can see that 1 to 8 is 17.5. So here it is A. Again from 2 to B. 2 to B also 17.5. Okay. Next 2 to C we have 30. Next 3 to D again 17.5. Again 4 to E also 17.5. Next 1 to 4 F is 30. Okay. So now we will join it to construct the hexagon here. Okay, so it is done. Now we have to consider a height of 5 boxes. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, here and again 17.5, 17.5, also 17.5, 17.5, 30, so 30. So we can join to here. Okay, these again you can give 1, A1, B1, C1, D1, E1, so F1 to F. So I can join A2, A1, B2, B1, C2, C1. Next we have D2, D1, and E2, E1. Okay, so it is joined. So we draw another hexagon here. So hexagon it is done. Now I have to construct the sphere. So from the center of the box. Okay. So from the center of the box. So 3.5 means here and 3.5 here. So from the center height we have to consider, that is 30. Height 30. So 1, 2, 3 here from this point, taking compass measuring 30 mm actual. So we know that sphere will be drawn with the actual dimension. So take 30. So from this end that will draw a circle here. Okay, so draw a circle. So it is nothing but a sphere. Okay, so this completes the problem. Problem number 7 from isometric projection. You can see in this square pyramid of base height 40 mm and heights 70 rests symmetrically on a cube of edge 50, which itself is placed on a cylinder of diameter 80 and thickness 30. So here it is a combination of 3 solids. First one we have to do, that is cylinder. Second cube. Above it we have to place the square pyramid. So for this I will take the reference line here. So here it is 18 mm there. So 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 6, 7, 8. Okay, 8 by 8 cylinder it is. So if it is an cylinder means we have to go for 4 arc by center method. So ellipse it is done. Now thickness it is 30. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Another ellipse. Marking middle points here. So draw the diagonals here. So you have to connect this point with this point with this. Okay. So cylinder is done. Above it you have to place the cube of its 50. So cube having 50. So we do subtraction by what was it? 80 minus 50, it is 30. Divided by 2 means it is 15. So above it 15 mm. We have to subtract. So now here we are getting this cube of 50 from this end, so height of 50, 1, 2, 3, 4, 5. One, two, three, four, five. And from this one, 1, 2, 3, 4, 5. So now square pyramid of 40. So 50 minus 40. So it is 10. 10 divided to 0.5. So 0.5 into R. This point so from this point height of 70. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 4. So then you have to join height of 70 and then join. Okay, so this completes the problem. We are going to do this problem, so similar to using side view. Okay, so just see how I'm going to do this problem. First I will be drawing reference line here. Okay. Now from this end I'll be leaving a high, because you can see that this is a cylinder extruded from the center of it, so we have to leave the 60 mm distance, that is 6 boxes, 1 2 3 4 5 6. So after leaving here we have to construct a box here. Okay, so from this end 1 2 3 4. Okay, so 1 2 2 we have 1 2 2 we have 3, that is 30 mm. So 30 means 3 box, then vertically upward by 60, 1 2 3 4 5 6, and again 30. Okay, then to join this, now we have to give the thickness for this. Okay, so thickness of how much? 30 again. So 1 2 3, thickness of 30 we have to keep. Again height of 60. So we can join it here. Okay. So this is the rectangular block. Now we have to construct this cylinder. Okay, cylinder of diameter 30, length 60. You can see the diameter 30 and length 60. So diameter 30 means here we have 60. So 60 means 1.5 box we have to subtract. Okay, 1.5 box on either side and subtract. So we get a box here now. Now we have to construct an ellipse here. So we have to go for 405 centimeter. Take the ellipse here, compass measure in this length, so why not same way here. Take from this end, so we have done the ellipse again. So we have to extrude here. So from this reference point we need to consider 6 boxes, 1 2 3 4 5 6, 1 2 3 4 5 6. So this is our point. So move from this end 1 2 3 4 5 6, and from this end 1 2 3 4 5 6, and from this end 1 2 3 4 5 6. Okay, here we have to join. Now we can mark the middle point with this box. Again another ellipse you have to draw here. Okay. draw the diagonals here. Okay, so diagonals. So now we are going to join from this end to here, and then from here to here. So this completes the problem. Okay, we solve another problem in isometric. That is problem number 18 in CAD solution book. Here, the rectangular pyramid of dimension 40 into 25. Okay, 40 into 25 we have to construct. And height of 50 is placed centrally on a cylindrical slab of diameter 100. Okay, first we have to construct a cylindrical slab of diameter 100. Above it we have to place a rectangular pyramid. Okay, so first we have to construct a boxes here, box of 100. Okay, thickness also given 30. Okay, from this reference point 100 means 10 bucks 1. So from this point 1, 2, 3, 4, 5, 6, 9, 10. 1, 2, 3, 5, 6, 7, 8, 9, 10, 2, 3, 4, 5, 6, 9, 10. Okay. So first we will construct a box of 10 here. So cylindrical slab means it is a circular, and here we have the diameter given. So that means, so mark the middle point. We have to go by 4R by center method. So taking the compass. So ellipse done. Now we have to consider a vertical height, thickness of 30. 1, 2, 3. Just mark the point, don't draw vertical line. Just you have to mark the point 1, 2, 3. 1, 2, 3. Here again, we construct another box. The box of 100 by 100, it is 10 by 10. Again mark the middle points. Exactly, middle point means 5 boxes here. correct length here. It is very important. Okay, so it is done. Now we see here, so diagonal lines, because it is in cylinder, so we have to draw the diagonals here. So now we carefully see it, we have to connect these points. Okay, vertically we have to join. So this completes the cylinder. So above it you have to construct a rectangle or a pyramid of dimension 40 into 25. So 40 into 25. So you can place 40 here or here. So you have to do, so say 100 minus 40 means it is 60, divided by two sides means 30. So on this top side I'm going to mark 30 here, 30, and from this side also 30 and 30. Okay, so 30 is marked. Second draw line here. Okay, again now 100 minus 25. So 100 it is 75. 75 divided by 2 means it is how much? 37.5. so we have to mark here this side 37.5, 35, 37.5 approximately. You can mark 37.5 from this end also. 37.5. so from this end 37.5. Okay, so now here you can see this is our rectangle. I'm going to make it dark. Okay, you can see that we have to have here this is a rectangle. This is 40. By 25, this one. by 25. So this is our rectangle. Okay, so I'm making it as dark. Okay, 40 by see that's what 10, 20, 30, 40. This is 25, 20, 20, 2 here 25. So here now by taking the center, so by taking the center, so I have to draw an axis length here. So from this center point we have to consider a height of 50 here from this end. 1, 2, 3, 4, 5. So height of 50 we have to do. Now we have to join it. Okay, so you can see that this rectangular prism, it is done. So it's completed. The next problem we are going to do, that is using these side views, okay, and the thickness, we are going to do the isometric projection. So herein, so first I am going to take draw and the reference line here. Okay, so from this reference line you can see that I am going to do like this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, so from this 1 point 1 to 2 we have 60. So remember, here horizontal lines will be drawn with the 30-degree inclined lines, and the vertical lines either vertically down or upward, it is drawn vertically only. Okay, vertically straight. Okay, horizontal lines drawn in the 30-degree inclination. From 1 to 2 it is 60. 36 boxes. 1, 2, 3, 4, 5, 6. So okay. Now vertically downward 2 to 3 we have. We see that this is 60, this is 30. That means this is 15. That is 15. So vertically downward by 15. Okay. Now again 30. So from this end 1, 2, 3. So 30. And then again thickness 60. 1, 2, 3, 4, 5, 6. Okay. 6 here. And then again 30. So from this end, okay, 1, 2, 3. Again vertically downward. This is 2, this is 3, this is 4, this is 5, 5 to 6, again 30, 6 to 7, again 1.5, that is 1.5 box downward. Okay, and then again 60. And now we can connect it. Okay, so we can give a thickness of 30. You can see that thickness 30. So I'm going to give the thickness 30 here on all the sides. 30 means 3 box. Okay. So 31 thickness we have to give. So here I'm going to join. Okay, now we're going to join this. So like this. So this is going to complete the problem. See that thickness given. So T shape we have been achieved. Okay. So like the video, subscribe and click on the bell icon. Okay. Okay, we do another problem. There is problem 32 in solution book. Here you can see they have given front end side view of it. Using this we have to do the isometric. Okay, so first I'm going to draw reference line. So from this reference line, so we have to give a length of 60. 60 means 6 box. So this one I'm going to do first, then after that I will do this one. 2, 3, 4, 5, 6. Okay. And then thickness of 1.5. 1.5 means 1.5 box. Okay, and here it is having a width of 25. You see that 25 means 2.5 box. 1, 2, 2.5. Okay, 2.5 thickness we have to give every weight. Okay, so it is 2.5 is here. Okay, so now we can give okay, this is joined. Now we have to draw this one. So it is having a width of 10 the both side. Okay, so draw this one also here for a dimension of 60. Okay, so here we have to give a dimension of 10 here. Okay, Here also it is 10, so I'm marking for 10 here. Here also 10. Okay. Now vertical height of 60. So 1, 2, 3, 4, 5, 6. 60, and it is having a thickness of 15. You see it, 15. So thickness of 15 means 1.5 here. Okay. So from this end also it is 1, 2, 3, 4, 5, 6. So here okay. So this completes the problem. Here you can see that, so you can erase this part and this part. Okay, so this completes the problem. So we are going to do this problem. So you can see in this problem a triangular prism base height 30 and length 60, length 70, resting on a rectangular face. So triangular prism which is having a rectangular face, so resting on a square slab of side 70 and 25 mm thickness. So first we are going to do this square slab, and second on it we have to place a triangular prism here. Okay, first I am constructing the square slab now. Okay, so from this end 70 box 1, 2, 3, 4, 7. Okay. 4, 5, 6, 7. So thickness 25. 25 means 2.5 bucks. Okay. So join. So square block is done. Now we have to construct a triangular prism, base side 30 and length 70. So the base it is having 30, so it is 70 means 70 is triangle subtraction this method. So it is 70 divided by 2. This is 20 on either side. So 1, 2. 1, 2, and here also 1, 2, 1, 2. Okay. So 70 means. So here 10, 20, 10, 20, 30. So left with 30. So here we need to, from the center, we need to consider a height of 25. Okay, from the center here, height distance we have to consider this 25. Okay, so from this end 10, 20, 25. So I'm drawing an axis here. So now we are going to join this. same thing here. From the center of it, consider height 1, 2, 2.5, 25. Okay, join here also. Now we join it from this top end. Okay, so this completes the problem. Okay, so this completes the problem. Okay, we do another problem in it. Okay, it is problem number 42 from the CAD solution book. Herein we have to construct two rectangle plates placed centrally over it. One will having dimension L into B into H, length into breadth into height. So one rectangle of 100 into 60 into 20, another of 100 into 40 into 25. So first I'm going to construct here. So from this end, 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 60, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 7, 8, 9, 10. So the thickness we have to give 20. 1, 2, 2. So here join this. So done. Now another rectangle of 140 into 20. So only difference you can see here 60 and 40. So 60 minus 40 means it is 20, divided by 2 means it is 10. So on the 60 mm side, subtracting by 10. Okay, here. So again, vertical height from this end it is 20. 1, 2. So this completes the problem. So welcome. So it is a problem number 4 from CAD solution book in the isometric projection. You can see here the following figure shows the top view of a cylinder. So here cylinder which is centrally mounted on a frustum of a pentagonal pyramid 60 mm height. Okay, so you can see in this problem, so this is our question. So this is our question. Okay, you can see in this they will be giving this top view of it. You can see that one pentagon of dimension 50, another pentagon of dimension 20, and this is our cylinder which is having a diameter of 40 and length 100. Okay, so they will give this one. So for this one, we know, as we have discussed, so if the polygon is given like triangle, pentagon and hexagon, we have to draw the orthographic of it. So herein I have drawn a pentagon of dimension 50 another pentagon of dimension 20. Okay, so in this above it I have placed a cylinder here of diameter 40. You can see it. So first I am constructing this pentagon. Okay, here because it is in Frustum, so herein I will take draw an reference line here. Okay, so say this is our reference point. Say here first I will construct this from 1. You can see that from 1 to 2 we have 80. 80 means 8 boxes. 2, 3, 4, 5, 6, 7, 8. Okay, then so this point it is 2. 2 to 3 we have 75. 75 means 7.5 box. 1, 2, 3, 4, 5, 6, 7, 7.5. Then this point is 3. Again from 3 to 4 it is 80. 80 means again 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this point it is 4. So now we are going to join. After that you can see 1A and 2B. With 2 to B it is 15. That is 1.5 box. These two lengths were same. Okay, so first I am marking 1 to A. 1 to A it is 15. 15 means 1.5 box. This is A. Then 2 to B, you see 2 to B it is also 15. 15 means 1.5 box. Okay, now from 2 to C. Okay, so 2 to C we have, so we have to measure. It is 2 to C we have, it is around 48 mm. Okay, so here I am going to mention it. It is 48 mm. Okay, so 2 to C. 2 to C it is 48. So 1, 2, 3, 4, 48 means it is around approximately here it is C. Now from 3 to D it is 40. 40 means 4 boxes. 1, 2, 3, 4. It is D. Now again from 4 to E, so I can take 1E. 1E it is exactly equal to 2C. That is 48. 1, 2, 3, 4. 48 means it here. That will be E. Now we are going to join these points to construct the pentagon. Okay, so it is done. Now so they have mentioned a height here, like a height of 60. So from this corner point we will be moving a height of 60, then we will construct this pentagon of 32. Okay, so from these corner points 1, 2, 3, 4, 5, 6. Okay, this point. Then again from this point 1, 2, 3, 4, 5, 6. Okay. From this point 1, 2, 3, 4, 5, 6. And this one 1, 2, 3, 4, 5, 6. Okay. So here we get another box. So we will construct. So remember, you should consider this only height, not the, don't draw vertical line. If you draw a vertical line, it will become prism. Okay, so remember it. So after getting the box here, so you can see this is our box of 32 by 19. So we have to subtract. So either here we have to get inside box of 32 by this 32, and we have this one we have to measure, and this is 32 by 30 box you have to get. Okay, 32 by 30. So how to do it? We will subtract with the, say, this 80 mm with the 32, this 75 with the 30. So that's how we do it. Subtract 80 minus 32 means it is how much? It is 48. Okay, so 48 divided by 2 means it is 24. So on the 80 mm side, so on the 1, 2 and 3, 4 we have to subtract by 24. Say here in this 24 means 20, 24 here 1 point, and from this end also 20, 24 here also 20, 24, 20, 24. Okay, now again this end 75, this is 75, this is 30. 75 minus 30 means it is 45. So 45 divided by 2 means it is 22.5 on the 60 mm side. Okay, this is 60, this is 75, so in this 22.5. So 22.5 means here in here 15, 25, 22.5 means here, and the same thing here also. So 22.5, so we have to mark, right? This 15, this is 20, 22.5, and here also it is 22.5, and here also it is 15, 20, 22.5. Now we are going to draw the lines. Okay, so now we are getting a box of here 32 and 32 and 30. Okay, so this is our box of 32. So I'm going to mark this is 1, 2, 32, 3 and 4. So this is our box. Okay, getting a box. Now 1 to A, so 1 to we have A, it is 6. Okay, 6 means here I'll mark this is A. Again from 2 to B it is also 6, this point. Then from 2 to C it is 19. So 19 means 19, 6. Again 3 to 4, 3 to D it is 16. So 16 means exactly here at the point, this is D. Again from 1 to E, you can see that 1 to E and 2 to C it is same, 19. So 1 to E it is 19, and it means it is E. So now we are going to join. So approximately we have to mark it. Okay, so here also we get the pentagons. Now we have to draw the slant edges. So we have to connect A with the A, B with the B, and C with the C. Okay, slant edges. Okay. So it is Frustum of pentagonal pyramid, it is done. Now we see in this diagram from the center point, so it is at a distance of 20 because it is 40, right? So what we do, so this is our box. We will draw a perpendicular bisector. Okay, so this is our center point. This is from this center point. From this center point we have to consider a box of 2. Okay, so from here this point, box of 2, 1, 2. Okay, here also 1, 2 we have to consider, and here at the distance of 20 and 20 you have to draw consider a from this end to from this end 5 boxes. Okay, because total length is 100. You can see that the total length we have here, it is 100. So from these marked points we have to consider 5 boxes. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. This end also. 1, 2, 3, 4, 5. Okay. From this end 1, 2, 3, 4, 5. Okay. So we're getting here 100 mm. Now from here we have to construct a box of 40. You can see that it is of diameter 40. So from this end 1, 2, 3, 4. In this end also 1, 2, 3, 4. So what we do? So we have to draw a cone here. So this is 40. From here we will be moving vertically 1, 2, 3 and 4. In this end also 1, 2, 3, 4. Okay. So we have to join it. So after this from these corner points we will be marking middle points. Okay, exactly the middle points. It is to draw ellipse we are going for 4 by center method. So ellipse is done. So here in this point also, these two are the end points. Again here 4 boxes we have to consider. 1, 2, 3 and 4. In this point also it is 1, 2, 3, 4. Again marking the middle points. Drawing in 4 by center method. Again we have to construct the cone here. Ellipse is constructed. Now we have to join these two ellipses to draw the cylinder. Okay. So we'll be joining these corner points. Okay, remember these corner points will be joined. So this completes the problem. Okay. Problem number 23 from isometric projection from CAD solution book. So in this problem they have given frustum of cone base diameter 50 and top diameter 25 and height 50. So frustum means it is a cutted portion of the cone. Okay. So frustum means it is a cutted portion of the cone. So base diameter 50, top diameter 25 and height 50 is placed centrally on a square slab of side 100 and thickness 30. So first we have to construct a square slab. Above it we have to place the frustum of cone. Okay. Square slab of side 80. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. So thickness 30. 30 means 3 parts. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So square slab is constructed. Now frustum of cone diameter 50. So this is 80. So base diameter 50. So 80 minus 50. So it is 30. Divided by 2 means it is 15. So 15, 1, 5, 15, 15, 15, 15, 15, 15. Okay, so this is our square of 50. So here we have to construct a ellipse here. So marking the middle point. So on top diameter 25. So we should consider a height of 50 from this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have to subtract in this, but you can see that top face diameter 25. So we have, this is 50, again we have to subtract 50 minus 25 divided by 2, it is 12.5. So 12.5, this is 5, this is 10, 12.5, 10, 12.5, 10, 12.5. 12.5, 12.5, 12.5, 12.5, sorry, 12.5, 12.5. So here now this is our square. So midpoint we have to mark. So now so two ellipses are constructed. Now we have to join tangentially. Okay. So this completes the problem. Okay. Welcome to Engineering Visualization channel. Problem number 23 from CAD solution book. A frustum of cone diameter 50, top diameter 25 and height 50 mm is placed centrally on a square slab. So first we are going to know what do you mean by frustum. Frustum means it is nothing but cut portion of the solid. Okay, cut portion of the solid to a particular height. So here you can see, here it is a frustum of cone. I am going to write that how it is look in front view. So here in the frustum, it consists of frustum of cone. It consists of two circle here. One is 25 mm top circle, and the base circle here it is 50 mm diameter. Okay, so and it is having a there are two circles which are at a height of 50 mm given in the question. That means both the top and the bottom part will be the circles which is of diameter given in the question. Place centrally on a square slab of 80 mm side and thickness 30. So first diagram we have to construct, that is a square slab. Square slab dimension given, side of 80 mm and height, that is thickness given, that is 30 mm. Okay, so above it we have to construct the second diagram, that is our frustum of cone. Okay, in order to construct the frustum of cone, they have given the dimensions here. So base diameter given, it is 50 mm. Okay, base diameter 50 and top diameter 25 mm. Okay, and height also given, height it is 50 mm. Okay, so first we need to construct in isometric, that is our square slab. Okay, square slab. First I will be drawing one horizontal reference line. Okay. Okay, to construct the square slab, they have given the dimension 80 mm side, that is 80 mm box we have to construct. So here square slab will be constructed using box method. Okay, first I will be drawing one horizontal line. Okay. Horizontal line. Okay, mark one reference point here. So here 80 mm means 8 boxes we have to count. So 8 boxes. Okay, so join all these points to get a box here. Okay, try to join a straight line. Okay, so again count 8 boxes and mark a point and then connect now. Okay, now we have to give the thickness here for this box. Okay, and it is, you can see all these lines were at an angle of 30 degree. We can show this 30 degree angle. Okay, and here given it is thickness 30, 30 means 3 boxes. Vertical height we have to consider. Thickness means it is nothing but height. Okay, 3 boxes you can mark here. 1, 2, 3. 1, 2, 3. Here also 1, 2, 3. Okay, draw the vertical lines here. Now connect these top end points with the box here. Okay, so here square block it is completed. Okay, now we have to complete this frustum of cone. For this they have given base diameter, top diameter and height. Okay, on the top of this square slab we have to place the base of 50 mm. For this we will be using subtraction method. Okay, subtraction of box method, we can say that. Say subtracting the boxes. Here we have top box of 80. So we need to subtract with the 50. 80 minus 50 means it is 30 mm. So it is on either side means 15 mm. So we need to subtract the 80 mm box. Okay, so at a distance of 15 mm. Okay, we can write 15 mm easily on the top box of 80. 15 here, 15 here. Okay, again 15 here, 15 here, 15, 15. You can mark easily. Okay, now we need to draw the where we have marked these points, right? We will be drawing with the thin lines here. Okay, now we'll get another box here, another box inside. What we get, that is of dimension 50 mm. Okay, 50 mm. Now here we have to construct a circle. When it is constructed in the isometric, okay, it will be constructed as a ellipse here. Okay, ellipse. So we will be using 4 arc by center method. So draw the ellipse. So here, as we know, the circle will be converted as an ellipse here. So ellipse will be constructed using 4 arc by center method. 4 arc by center method, you can say that. Okay. First I will be marking the midpoint of this 50 mm. Okay, so mark the midpoint here of the inside box, exactly midpoint at 2.5 you can mark. Now draw the lines here, 4 lines you need to draw. Okay, okay, so we have drawn the 4 lines here. Now measure this line and draw an arc here. We have to draw an arc. Okay, now taking that as a reference point. Okay, you can subscribe to the channel and hit on the like button and share to maximum students so that they can be benefited. Okay, these are all the problems in the CAD solution book. It is very helpful for the first year engineering students. So they are studying this engineering graphics or computer aided engineering drawing subject. Now we have completed the base diameter 50, that is we have drawn an ellipse here. Now by taking 50 mm the inside box, so we have to consider the height here now. The height of 50, so count the boxes. So here the box count, it is coming from exactly the center of it. So count 5 boxes, and again here we need to construct another box of 50. Okay, from there we will again subtract, so that we will get another box of 25. Okay, now I will be drawing another box here, box of 50 by 50 at a height of 50 mm. Okay, just we need to count here, don't draw vertical lines. If you draw the vertical line, it will become prism. Okay, so it will become prism. So connect it with the thin lines here. So box of 50 by 50, you got it. Now here the top diameter, it is 25. So but we have drawn a 50. Again now subtraction of box method. 50 minus 25 means it is 25. So you have to subtract on either side, means it is 12.5. 12.5 mm we have to mark. You can see on this the top box. So this is 10 here. So 10 means it is 12.5 here we have to mark. In the same way here also 12.5 we have to mark. Okay, on this side also we have to mark 12.5. Okay, here also on the top box we have to mark 12.5. Here also 12.5. Okay, 12.5 we have to mark. Now draw the lines where we have cut it exactly at 12.5. Try to connect with these lines so that we get another box of 25 mm. Now you can see the inside we getting a box of 25 mm. Okay, the inside box, will consider that as a reference. Yeah, those are the corner points of that particular box. So mark the midpoints now. Again we use the 4 arc by circle method, 4 arc by center method to construct the another ellipse, because that is a frustum of the cone. Okay, in a frustum of cone we have both top and bottom will be the circle. So when it is constructed in the isometric, it is becoming as a ellipse. Okay, so subscribe to my channel and hit on the like button and share it to maximum students so that they can be benefited. Okay, draw an arc here to construct the same way how we have constructed the bottom ellipse, right? Same method we have to do it. Now draw horizontal lines connecting the corner points here. So now join here. Tangentially you can draw here. Okay, so that completes the problem. So here you can see we have completed both. This is nothing but your square slab. This is your frustum of cone. Thank you all. Thank you for watching the video. Subscribe to my channel and share it to maximum students so that they can be benefited. Thank you guys. Problem number 25 from CAD solution book. So it is a problem from isometric projection. A hemisphere of diameter 50 mm resting on its curved surface centrally on the top face of a frustum of a rectangular pyramid of base side 80 into 60 and top of 60 into 40. So with the height given 55. So first we have to construct a frustum of a rectangular pyramid. Okay. So first we construct this 80 into 60. 1, 2, 3, 4, Now, so we need to consider a height of 55. 1, 2, 3, 4, 5, 55. 1, 2, 3, 4, 5, 55. 1, 2, 3, 4, 5, 55. 1, 2, 3, 4, 5, 55. So we need to get a top of 60 into 40. So that is 80 minus 60. 20 by 2 is 10. 60 minus 40, 20 divided by 2, 10. So on the either side we have to subtract by 10 here. So now we are getting so first term of a rectangular pyramid it is done. Now you have to keep the hemisphere of diameter 55. So for that you need to consider a height of 25. So 1, 2, 2.5. 1, 2, 2.5. 1, 2, 2.5. 1, 2, 2.5 here. In the box. But here we need a box of 50. So here we have 1, 2, 3, 4, 5. So this is 50. But this one is it. 1, 2, 3, 4. here. So this will become 50. 1, 2, 3, 4, 5. One, two, three, four, five. This is 50. Okay. This is 58. But here you have to get 1, 2, 3, 4. Now you see it, and this is our box of 50. So marking the entry points. So from this point, measuring this length, into okay, so this completes the problem. A regular pentagonal prism of base side 30 mm and axis 60 mm is mounting centrally over a cylindrical block of 80 mm diameter and 25 mm thick. So draw the isometric projection of the combination of solids. So here I will be drawing a top view, the orthographic view of this pentagon and then a circle. First I will be constructing a pentagon of dimension 30 mm. So draw a vertical line of 30 mm. So take protractor and mark for 72 degree. You all know how to construct the pentagon with the angle of 72 degree. Okay, draw a line of length 30 mm passing through that angle point. Okay, so here also you need to mark for 72 degree and draw a line of length passing through that angle point, a length of 30 mm. Okay, So now you take compass, measure 30 mm and cut the arc. Okay, so now you join with the help of a scale, straight line you draw connecting it. So this completes the pentagon, dimension 30. Okay, so now to find out the center of this, I'll be drawing first I'll be drawing middle points to draw the perpendicular bisectors. Okay, at least I will draw 3 perpendicular bisectors, marking the middle points. Okay, so this is how you have to draw the perpendicular bisector to find out the center of the pentagon. So here I have drawn 2, so I need one more. Okay, one more. So mark the middle point. Okay, so 30 means exactly you need to mark for 15 mm here. Okay, so okay, after constructing it, so show the dimensions. So it is having a dimension of 30 mm. Okay, now we should construct a box for this, because we will be constructing using box method in the isometric. Okay, that's why we need to construct the boxes here, or the extremities of this pentagon. We will be drawing horizontal and vertical lines. Okay, so that we can able to construct a box for the extremities of this pentagon, so that within this we will get a rectangular box here for this pentagon. Okay, we should construct it. Okay, you can measure the dimension and show it. Okay, it is around 49 mm we get here. Okay, the middle point of that will be 24.5, and this is vacating around 45 mm. Okay, and this one also we should measure. This is we are getting around 28 mm we get here. Okay, the total length we get, it is 45. We should measure these lengths, because so it will be helpful when we construct this pentagon. So because it is in polygon, so that's why we should have all these lengths. If we measured these lengths, okay, box dimensions and this end points length, so it will be easy for us to construct it. Okay, so it is having a length of 45 mm. We will show it. Okay, now from the center of that we will be constructing a, here it is a cylinder block, means it will be a circle. So the diameter given 80 mm, so we will be considering a radius of 40 mm here. Okay, then we construct a circle here. So that means it is having a box dimension of 80. We no need to see, but we can show only the dimension. So we will show the dimension on one side. So the box dimension of this cylindrical block, it will be 80 mm. Okay, now we need to construct the isometric of it. So you can see we have the first we need to construct a box of 80 by 80, that is 8 by 8 box. First I will draw a reference line. Okay, then we'll take a reference point. From that reference point, okay, I'll be counting 8 boxes. Okay, 2 3 4 5 6 7 8. This side also I'll construct the same thing, 4 5 7 8. Okay, so construct the box first. So here it is a cylinder, means we should construct the ellipse here. We should construct the ellipse here, 2 ellipse at a height of 25 mm, because it is having a thickness of 25. So the height we should consider, that is 2.5 box. 1 2 2.5. Okay, again same thing we should do it for all these extremities, 2.5. Again 1 2 2.5. 1 2 2.5. Okay, so here also we should construct another box of 80, that is 8 by 8 box, 80 mm, 80 by 80 mm. So we should join these points which we have taken. Okay, so now we got the box again here. So now we should mark the middle point of this box. So it is 80, means exactly at 4 boxes. Count it perfectly, 1 2 3 4. Then 1 2 3 and 4. 1 2 3 4. Same thing here also, 1 2 3 4. Okay, count again, 1 2 3 4. So mark it properly. Now you draw the lines from the corner of the point to the opposite middle point. Here we are following 4 arc by center method to construct the ellipse. You all know how to construct it. Okay, 4 arc by center method. Okay, then in the top box also we should do the same thing. Okay, now use compass to measure these lengths and cut the arc. Okay, measure the length, any one length. You can construct these arcs same way from the other end. Okay, join it properly. And then from that reference point we construct part of the ellipse. Okay, the same way we should do it for the top box also. Okay, from that reference point. Okay, measure the length and cut the arcs to construct the ellipse here. Okay, now you draw the diagonals for the bottom box and the top box. The straight line you can join, connect. Okay, for this point also you can do it. Okay, now we can join these extremities with the vertical line here and here also. Okay, so now we have to use the subtraction of box method. Okay, so one side we have 80, one side we have 45. 80 minus 45, it is 35. 35 divided by 2 means 17.5. And the other side we have 80 minus 49. 80 minus 49 means 31. 31 divided by 2, we have 15.5. So that means on the one side we should mark 17.5 on the other side of the line, and the other box side we should mark 15.5. It is almost around 15 only. So that's what the thing I'm going to do it on the top box. So on the top box I should mention, okay, you can see here the top box we should mention one is 15, one is 17.5. You can mention it. So first I'll be mentioning 17.5. From this side also 17.5. There also I should mention 17.5, and here also 17.5. Now on the other side we should mention 15. 15 we should mention 15, 15, 15 and 15. Okay, so now we'll draw the lines connecting these points. Okay, and join these reference points also with the straight thin lines, because we will get a box here for, we'll get a rectangular box for this pentagonal prism. Okay, now we need to find out that, and we should dark it so that it will be easy for us to construct the pentagon within that rectangular box. Okay, box of 45 by 49 we get it here. Okay, okay, now you can see we should we have already measured the box in the pentagon. We should use those point lengths such as 9, 28 and all. I'll be marking 9 here, you can see on the either side, and then I'll be marking the middle point, that is 24.5. okay, and then I'll try to join. Still I need to mark 28 here, so 28 I'll be marking. So this is where I'll get 20, 28 here. Okay, here and here. Okay, and then I'll join these points to get the pentagon here. Okay, so by joining all these points we get a pentagon here. Okay, so from these pentagon extremities exactly vertically upward we should move at a height of 60 mm, that is 6 boxes. Therein also we need to construct another pentagon. Okay, another pentagon. So from this extremities point, so using scale we can count the boxes here. Okay, I can count it. I'll be using the help of the scale here, that's it. But I'll be counting the boxes only here. Okay, 1, 2, 3, 4, 5, 6. Okay, that is your reference point. Okay, draw vertical line because it is a prism. Same way for this 1, 2, 3, 4, 5, 6. Draw a line. Okay, same way here also. Why I'm using scale means it will be helping to draw a straight line. 1, 2, 3, 4, 5, 6. Can join. Okay, the same way here also. Can do it. Can count. 1, 2, 3, 4, 5, 6. Can join here. Okay, and then here also we can do it. 1, 2, 3, 4, 5, 6. Can join. Okay, now we get a pentagon above it, so you can see that at a height of 60. So we should connect it. Okay, we should connect it. To get the pentagon here. So you can see, so that completes the problem. You can see that the subtraction of the things we have done here. Problem number 39 from CAD solution book. It is a frustum of square pyramid, base height 40 mm, top face height 20 mm and height 40 mm is placed centrally on a frustum of a cone base diameter 80 mm, top diameter 60 mm and height 20 mm. Draw the isometric projection. So in this, first we have to construct the frustum of cone. Okay, for that they have given base diameter 80. So for that we have to construct the box for it. First I am taking a reference line here. So count 8 boxes. So it is a cone means it is a circle. Circle means we have to construct the ellipse here. Okay, we have to construct the ellipse here. Using 4 arc by center method. So taking the compass, we can construct the ellipse here. Taking the lens, measuring the lens. Now on the top circle, it is at a height of 20 mm. So we consider a height here of 2 boxes. Don't draw vertical line here. You have to just count the 2 boxes and draw again a box of 80. So here we need to get a box of 60. So we are subtracting 80 minus 60 means it is 20. So on either side means divide by 2. So 10 we get. So we have to subtract by 1 box here on either side. Now we are getting a box of 60. Just I am marking the corner points of the box. Again 4 arc by center method. Mark the middle point of the box. So here it is 60 means mark exactly the 3 box. So again 4 arc by center method to construct the ellipse here. here we have to draw a tangential line for the two ellipses with the curved surfaces. Okay, so like this you have to draw in this. So here also same thing. So above it we have to construct the frustum of a square pyramid. So it is having a base of 40. So but we have a top face of 60. So we are subtracting 60 minus 40, it is 20. Either side means it is 10. So height they have given it is 44 boxes we have to count. Again we have to subtract because top face it is 20. 40 minus 20 it is 20 divided by 2 means 10. So on other side you have to subtract by 10 means one box. Now on the top face we get a box of 20 by 20. We see problem number 50 from CAD solution book in isometric. You see in this problem they have given rectangular slab of side 100 into 80 and height 30 as a full depth coaxial square whole of side 40. So first we are going to construct rectangular slab here. From this 100, 1, 2, 3, 4, 5, 6, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 100 by 80. That means 10 into 8. Height we have to give 30. 30 means 3 box. now we have to have square rule of side 40. So we have 100 into, so 100 minus 40, it is 60 divided by 2 means 30. Then 80 minus 40 means it is 40. 40 divided by 2 means 20. So on the 100 mm side, so we have to mark up 30. So on the 80 mm side, we have to mark up 20. So now we got the square of 40 here. I am going to mark it. So this is 40. So we have to give a height of 30. This is thickness having 30. That means you have to give a depth of 30 here. So thickness 30. So vertically, so 33 box. Then so 30. So you can see that so this completes the problem. Square prism of base side 40 mm and height 50 mm is placed centrally on a cylindrical slab of diameter 100 mm and thickness 30 mm. So here first we should construct a cylindrical slab. That's why I given number 1, cylindrical slab. First we have to construct. Okay. Second thing, we should construct above of it, that is a square prism. So the dimensions we can write down. So 100 into 30. This is 40 into 50. Okay. Okay, in the isometric sheet, you take the reference line. Okay. Okay, from this reference we should mark 110 boxes, that is 100 mm, right? We should mark 10 boxes on either side. Okay, so construct the square box here. Square box for 10 by 10. So we should draw here thin line for the square box because it is a cylinder. Okay, that's why we should construct this 110 by 10 box, that is 100 mm, with a thin line. Okay. Okay, now we should consider a height of 30 mm. Okay, thickness given 30 means 3 boxes we should consider, and we mark a reference point 1 2 3 1 2 3 1 2 3. Now here we should construct another box of 100 by 100, that is 10 by 10 box. Okay, 100 mm box you have to construct. Okay. Okay, after constructing this box of 10 by 10, we should construct the ellipse here. Okay, two ellipses we have to construct, and then we have to join to construct the cylinder here, cylindrical slab. Okay, so use the compass. So first we should mark the middle point of all these boxes. So mark the middle points for the both the top box and the you should mark exactly at the 5. Okay, midpoint we should mark. Okay, so after that we should draw a lines here from the corner point. Okay, either you can draw first, you can draw for the bottom face. See, from the corner point, so to the middle point what we have marked, we draw a line here. We know how to construct the ellipse, so we are following the same concept. From that middle point we are joining with the corner point here with the line. The same thing we do it for all the middle points. With the corner points we are trying to join here. Okay, and the same thing we will be doing on the top box also. So here I can use this length to construct the ellipse here. Okay, okay, then take this as the reference point. So measure this length carefully, you can cut the arc. Okay, so that is also having the same length, so you can cut here also by considering that as the reference point. Okay, now the same way we do it for the top box also. So we try to connect with this corner point with the middle point of the box with a straight line. Okay, okay, now we construct the ellipse here by measuring the lengths here. So measuring these lengths, you can construct the arc here. So measure it properly and construct it. Same way we should do it for the other side also. Measuring this straight lines length using compass, and we construct the arcs here. Okay, the same way do it here also. Okay, so now we got two ellipses here using these two boxes. Now I'll be drawing a straight line connecting these opposite corners. Okay, now we are going to join these points, okay, vertically with the straight line. Okay, that completes the cylindrical slab. Now above it we have to place the square prism, which is having dimension of base side 40 and axis length 50. So we have to go for the subtraction of box method here. So we have the box of 100. 100 minus 40 means it is 60. So we have to divide on two sides, means it is 30. That is 3 box dimension we should mark on the top box here. On the top box we should consider 3 box. On all either sides we should mark 3 box here to go for the subtraction of box method. It's because we should get a box of 40, right? Because square prism having a dimension of 40. So we can subtract by 30 mm on all the either sides. We can subtract it easily. Okay, now we get a square here of dimension 40. Okay, so for the square we should consider a height of 5 boxes, that is 50 mm from all these corner points. Consider a 5 box height from all those corner points. Okay, now draw the top face dimension 40 by considering a height of 5 boxes here. Okay, just draw connecting these two square faces by the vertical edges. Connect these corners with the vertical line here. Okay, so I can mention the angle 30 degree for the base where we have taken a reference. Okay, you can see this is our, so I can write cylindrical slab, dimension 100 into 100 and height 30. This is a square prism, dimension base side 40, height 50 mm. So that completes the problem. Problem number 49 from CAD solution book in the isometric. You see in this problem, a square prism side 40 mm and height 50 has a full depth coaxial square hole. Okay, full depth coaxial square hole, side 20. So it is one of the type of problem. Okay, it is a different type. So just see it how to do it. Just taking the reference line from here. So it is of side 40 and height 70. 40 square, that is 4. 1, 2, 3, 4. 1, 2, 3, 4. And height 70. So height 70 means 7 boxes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it is a square prism, then we have to draw these vertical edges. Now it is having a square hole size 20. So this is having 40. So we are going to subtract 40 minus 20 is 20. Either side means divided by 2. It is 10. So subtracting by 10. Either side. So here we have the square hole. So this is our square. So I'm going to draw it vertically downward. Okay. So this completes the problem. Draw the isometric projection of a rectangular prism, dimension 60, 80 into 20 mm thick, surmounting a tetrahedron of sides 45 mm, such that axes of the solids are collinear and at least one of the edges of both the sides are parallel to VP. So you can see here in this I have drawn the orthographic of the tetrahedron, both the top and front view of it I have drawn. You see that, that's what I am writing. Orthographic view of tetrahedron we required to construct here. Okay, you can see initially I have constructed a 45 mm triangle. Okay, then after that I have taken a mark the point, and then I have marked the middle point of all the edges to draw the medians here, and then you get the exact point. You need to draw the medians here, remember. And then I have projected the lines, and we don't know the axis length here, just projecting the line, and you can see the edge OBT is parallel, so we should measure 45 mm and cut the axis. So we should cut with respect to the 45 mm. We need to find out the axis. Here the axis length what we get, that is 36 mm. Okay, now after that we have to construct the box for it. Okay, we need a box. One side we have 45, another 40, and the exactly half of that is 22.5. Okay, now we need to construct the isometric of this. Okay, first we will be constructing a rectangular prism, then above that we will be constructing a this tetrahedron. Okay, I'll be using the isometric sheet because it is an isometric problem. So first take a reference line, you can see that. So first we have to construct a rectangular prism, so which is having a dimension of 60, 80 into 20 mm thickness. Okay, I'll be constructing a first I will take a reference line, then I'll be constructing a rectangular box which is of dimension 60 into 80. Okay, then after that I'll give the height of 20. So first you draw an reference line. Okay, you take one reference point. So from this reference point you consider the boxes here. Okay, 60 means 6 boxes. Okay, and 80 means 8 boxes. 1 2 3 4 5 6 7 8. Okay, now we can construct it. Okay, 1 2 3 4, can again recheck. So now we have to construct the box here, rectangular box, rectangle. Then after that we will be giving a height of 20. Okay, here exactly at all these points we need to give a height of 20 mm. Okay, you can see in the problem. So the thickness we should give, that is 20. Okay, that is 2 boxes height we have to consider vertically. Okay, thickness we consider in vertical height. And then rejoin to construct a rectangular prism. Okay, so join all these extremities to construct the rectangular prism here. Okay, you can mention the angle 30 degree on either sides. Okay, so now you can see we have this rectangle of dimension 60 into 80, but we need to place this tetrahedron, which is I need to place this 45 on this 80 and this 40 on the 60. So we will be going to the subtraction of box method here. 80 minus 45, so that will be 35. So 35 divided by 2, because we should consider on both the sides, that is 17.5. In same way the another side we have 60 minus 40, so it will be 20 by 2 means 10 mm. So we need to mark on the longer side, that is 80 mm, that is 17.5. okay, 17.5, that is more than 15. Okay, in between 15 and 20 we should mark. Okay, approximately, and then 10, so you can count exactly one box here. Okay, you can construct the thin line here. Okay, Okay, so now we get the internal box dimension 45 and 40. Okay, that's what it is, the box dimension of the tetrahedron, right? So you can mark the middle point and you join to construct the base of the tetrahedron. So base of the tetrahedron, it is a triangle. Okay, now we can find out the center of the box here. Okay, center of the box we find out. So for that we will drawing to take middle points here, and then we draw middle point of the box we consider, and we have to take the center point here. Okay, so we can consider the middle point of this by drawing median also we can do, that is also we can do it, or either we can consider the middle point of the box. So both the things are we can able to do it. Okay, whichever you find feasible you can follow that. So I'll be considering here middle point of the box. Okay, from that center point we'll be considering a height of 36. So that's what we have been find out from the orthographic height. We have been find out that is 36 mm. Okay, that's what we have been find out. So we'll be considering a height of 36 means 3.5 bucks, more than a half bucks, a little more than the 35. Okay, so you'll be drawing an axis line here. Okay, and then joining with the base of the triangle. So we should connect it. Okay. Okay, so that completes the problem.